great to see everyone. Thanks so much for coming to this presentation. So today we'll tell you a little bit about how to build in a multi-chain world with Axelar and USDC. So for those of you that are here, I guess I'm curious, how many were present a couple of days ago for the kind of Circle bridge announcement that the team has done? All right, everybody was there pretty much, so good. So then you have a little bit of context. So to rewind a little bit, just let me take a step back for a second and tell you why are we trying to kind of connect all the different blockchains, right? The very, very high level, if you think about it, what would the world look like if we lived in a very disconnected ecosystem today? It would be very different than what we're used to, right? If you think about it today, every blockchain is sort of a country. It has its own rules, it has its own language, it has its own smart contracts. They don't really talk to one another that well, or have not talked, to this date. And in the same way as kind of the communication infrastructure to transport goods, to transport information across different countries was fundamental to enable better economies, it is fundamental for the blockchain ecosystem, so we connect everything together to unify and to have global liquidity, composability, and better user experiences for the whole ecosystem. So we live in a multi-chain world that we need to connect, but the unfortunate reality is that today everybody's sort of fed up with multi-chain experiences, right? So if you think about it, we have developers that are always thinking about how do I take my application, and deploy it across multiple different stacks, multiple different blockchains. How do I manage it? How do I manage liquidity across them? What do I tell my users? How do I tell them to go from A and B to C and so on and so forth? So it's been very, very painful. And users, as a result, are suffering from all of this, right? They're suffering from fragmented liquidity, until kind of Circle started to do their work with USDC. You saw this like 15 different versions of USDCs on different chains with different representations. So now finally, we'll be able to canonicalize a lot of it and provide better user experiences. And at the end of the day, beyond user experience, the fragmentation of liquidity has monetary effect on the users, right? So if you look at this article by Stephen McKean, he talks about what is the price impact when the liquidity is fragmented across different blockchains, and how that price impact can actually be minimized if the liquidity was to be connected all together and have like unified liquidity across all of the applications that we have. So if you don't know what the price impact is, kind of take a look and you'll get a better sense. But at the end of the day, we just want to solve problems for two types of audiences. We have developers, and developers just want to solve problems for the users, right? They want to be able to build an application that meets users' needs, has very low fees, has fast speed, and they enjoy the programming environment, right? So there are a lot of blockchains where these properties at the end of the day can be met, right, with proof of stake chains, with fast finality, with thousands of transactions per second. And those are the environments that developers love. But while they're solving a problem, they want to make sure that users will be able to access and interact with their application, which today is very, very painful. And users need simplicity, right? At the end of the day, as a user, maybe you don't care about all those choices the developer had to make to decide what is the best platform to solve their needs. Maybe the developer wrote in Rust. Maybe they wrote in Solidity. As a user, you don't think about those things too much. You don't really care about most of those things. And all you want to do is be able to interact with any application, any chain, any blockchain with one click from your wallet, right? Like that's the ultimate user experience and the ultimate simplicity that we have to work towards. And so, without further ado, let me introduce you a little bit to kind of a sample application that we've been working with Circle and USDC to enable some of these, what I call is cross-chain native experiences. So I'm going to try to do a live demo today on stage, and if things go bad, we're going to switch to a recording. But things never go bad on stage, so it should be good. Let's give it a try. All right, can you see this? All right, you can see this. Okay, so very simply, what are we trying to do here? We have two different blockchains. We have Ethereum and we have Avalanche, and user wants to swap an asset from Ethereum with an asset on Avalanche, right? So let's say we want to, or the other way around, they want to start with, let's say, Avalanche chain as an example. So let me connect my wallet. I have some AvaX, so this is all running live on the testnet, and I want to swap it for ETH, right, on Ethereum chain. So pretty simple. Today, this is not possible, right? What would you have to do? You either go to a centralized exchange to do these operations, or maybe you get some wrapped version of one asset, bridge it over to another chain, hoping you find a liquidity pool and kind of try to get some gas for the destination chain and so on and so forth. So very, very complex. Now with this new experience, I simply specify how much I want to swap. It gives me kind of estimated amount. It's all on testnet, so the numbers may be kind of off because the pools are not deep. But I click, I confirm, and that's it, okay? And so what's happening on the hood, I'm going to walk you through in just a couple of slides. But essentially what happens is that AvaX from the Ethereum chain gets swapped for USDC, right? And USDC gets bridged over to the destination chain, being Ethereum in this case, and then USDC gets swapped for Ether on the destination chain, right? And why is it all possible and why can this all be automated and programmed is because we compose in kind of a Circle USDC bridge with Axelar infrastructure, functionality like relaying, and general message passing. So what that means is that any user intent can actually be coded into a program that gets shipped around from a source chain to a destination chain. And in this case, the program being a set of instructions that says the user wants to swap on the destination chain, like USDC for ETH. And they want to call like a Uniswap pool, for instance, to do that. So as you can see, everything has been done here. If I click on my wallet now and I, let's say, switch networks to the Ethereum testnet, I can see that I have some test ETH, and let me actually trace you through the transaction so you can see what happened under the hood. So in the first sequence of instructions, wrapped AvaX was swapped for Circle USDC, right? Circle USDC was bridged over using Axelar and Circle bridges, and we'll talk about that in a second. On the destination chain, we minted this USDC through the Circle bridge, and finally we called a program that swapped this USDC for ETH, for wrapped ETH on the destination chain, right? So it's these 3 steps of commands that actually have been all programmed and automated, included like in a general message, and that's it, right? And the user got their result at the end of the day, and it was very, very simple. So this is what I call as a cross-chain native experience, right? As a user, I never had to think about what chains my transactions were executed, how they were routed, how they were relayed, how do I even pay for gas on the destination chain. I didn't have to think about any of those things, so everything was taken care of on the back end for me. So awesome. Isn't it awesome? Awesome. Great. So now let me go back to the presentation just to give you a little bit of an architectural view of how these things worked behind the scenes. So this is a backup recording, so we don't need that. That's great. And so kind of before I get into the architecture, let me tell you, just to emphasize, why would you want to build these kind of cross-chain native experiences? And I always think about it and try to simplify it into kind of 2 buckets of problems that you may want to solve. And the first one is what I call is like a scalability problem, right? You have an application that probably has a product market fit, let's say a DeFi application, NFT marketplace, whatever that is, and you're looking to scale that application to the whole blockchain ecosystem, right? Definitely more liquidity, more users, and a global distribution would lead you to better application results, right? You would have users from Solana that can access your application. You can have users from Cosmos access your application. You'd have better liquidity. You can collect more fees and so on and so forth. So scalability of an application is kind of a critical component that at some point every application that found a product market fit will have to do. And so I think cross-chain is one path to do that. And the second one is what I call is the innovate bucket, right? We talked about it earlier. I think everybody's fed up with multi-chain experiences, kind of a wallet flipping and so on and so forth. And you can abstract all of that away, and you can really build a simple Web3 user experience that has this global distribution, global connectivity from any wallet directly to your application from day zero, right? And that's really the future where it's going to be. Okay. So now let's take a look at a little bit of what's going on behind the scenes, and I'm going to explain it in two phases. First, I'll tell you a little bit more about what Axelar Network is and how it works, and then we'll see how it composes with the Circle USDC bridge functionality. So on the very high level, Axelar Network is a decentralized, permissionless proof-of-stake network that can route information from one blockchain to another, right? And this information can be anything from token transfers to messages and general cross-chain contract calls. The architecture itself has 3 different layers. At the very bottom of it is what we call as a network layer, which is the Axelar network itself that's responsible for secure cross-chain message delivery and routing. So figuring out how do I go from chain A to chain B to be able to execute that payload in a secure way is what the network will be responsible for. On top of it, what we call is a service layer. So a service layer does things like relaying, one-click gas payments. It allows you to monitor the state of transactions. It allows you to recover if certain transactions were not propagated. It allows you to trace precisely what is the state of these transactions, and we'll talk more about those features kind of throughout the talk. And on top of it is a very simple API layer, right? So kind of an analogy you can think of it is kind of a Stripe API, but for Web3. Very simple interface. You specify, I want to go from A to B, and this is my payload, right? So you can access that API directly from your smart contracts, and underneath all of that is the kind of the complicated infrastructure that will take care of everything behind the scenes. So, and the powerful thing is that when you take the Axelar network and compose it with Circle USDC bridge, it allows you to build these native cross-chain applications. So first thing, you can compose Axelar general message passing with the asset transfer functionality. So asset transfer being kind of USDC transfer. And the general messages, when I refer to them, I really mean kind of an arbitrary program or a contract call that you can specify while you're transferring assets, right? So I want to take my USDC, I want to transfer it to this destination chain X, and I want this USDC to be swapped for ETH, and the result be given to the user, right? So that's a general message that you can pass around through the Axelar interfaces. You can use Axelar Network for additional validation, right? So when a message has arrived at the destination chain, what are the safety checks that I want to perform to make sure that I should actually execute it as an application? And you can encode this kind of a additional safety layer, what we call. And finally, you can use the Axelar infrastructure for these simple one-click cross-chain experiences, right? So monitoring, relaying, gas payments, all of that, you can rely using the existing Axelar infrastructure. And the result are these cross-chain native dApps with global composability and very simple UX. Okay. So this is what kind of the benefits are. Now, how do you actually combine the two things together? I will explain it in 2 slides first. One is a super high level architecture, and another one is slightly deeper. And then I'll pass it to Jackson, who's going to walk you through a little bit more in depth how these things can be built out from the ground up. So very high level, as you're building your application, you can think about building a series of application logic smart contracts that can be deployed across multiple chains, right? So in the same way as when you're coding on a single chain, you have smart contracts and they talk to one another, right? So maybe one contract locked some funds from the user, another contract is responsible for rewards, another contract is responsible for swaps. In the same way, you can design your application to have multiple contracts, but now these contracts can live on different chains and they can talk to one another through the Axelar underlying infrastructure and general message passing. So that's one. The second thing what we have done is we have extended a simple call for an applications to be able to perform a send USDC function with a message payload attached to it, right? So again, I want to send my USDC to Ethereum and I want it to be swapped for ETH, right? So that can be encoded and that can be called through the send USDC and message function call. You have all the relay infrastructure that will take care of those messages, relay it across multiple networks, and you rely then on the Axelar network for validation of the message, and you rely on the Circle bridge for minting and burning functionality of the USDC itself, right? So you get a native USDC, you don't have to think about any wrap versions behind the scenes. Taking it one step deeper, this is what the flow actually looks like. So if we start from the left and kind of go top to bottom, the user starts with an intent. An intent is, I want to swap ETH for AvaX. You have a contract on the source chain that would first do a swap of ETH to USDC, right? So you probably have some type of a pool of ETH USDC. You can swap it through Uniswap or any other DEX. And subsequently, you can call this interface that we exposed, which is a send USDC and a message. And this interface will take the USDC. It will take the message that you want to execute on the destination chain. And in this case, the message will be, now take this USDC, again, route it to the destination chain being Avalanche, and then swap it on Avalanche for, or Ethereum for the destination asset. You would send the message through the Axelar gateway that specifies the program that you want to execute. You would send the USDC to the Circle bridge. The Circle bridge will burn it on the source chain. Then everything goes through the infrastructure that we have built to relay these messages, to monitor, perform gas payments. And then on the destination chain, you have the reverse flow, right? Where Circle bridge mints the USDC. Axelar gateway validates the message and the intent that the user wants to execute. And then everything gets combined in another smart contract, which performs a swap on the destination chain to swap USDC for your destination asset and give the result back to the user. Right, so that's the flow kind of end-to-end. And you can kind of combine the infrastructure and these two functionalities in one incredibly powerful framework. So on that, I'm going to pass it to Jackson, who is going to tell you a little bit more about developer tools and how to think about building this very, very simple cross-chain native applications.
All right, cool. Thanks, Sergey. So yeah, I want to talk a little bit about how you as a developer, what your experience would be like building on Axelar, and the components sort of what this new cross-chain paradigm, how we have to think about the design patterns we use, some concrete examples, and then all of the services that we've built to automate all of the more complex parts of the cross-chain stack, and then all the tooling that we can use in a developer workflow. So this is kind of a typical, well, this is the full Axelar application stack. So at the bottom you have our network, which is connecting all of the different chains. Then you've got the contract logic, where like the work that you want to do as a developer is going to be stored. Then we've got our services, which sit on top of that, which you can access via your contracts. And then there are the services that you feed into your client, like user-facing application. And so as a developer, we really only want you to have about these two things, which is the contracts, what you actually want to manipulate on chain, and then how users are actually going to interact with it. So previously in cross-chain, what we've seen is this notion of sending the assets to the program, and that's really all we've been able to do, and it's been in this really clunky way where say if I want to take my Ethereum or my ETH on Ethereum and wrap it into like a liquidity pool on Avalanche, then I have to go through a bridge, then swap over to Avalanche, then execute a transaction to actually, LP into Aave or something. And it's this really clunky multi-stage flow. So we make that one transaction from the source chain and automate all of the intermediary steps. But also we enable this kind of new paradigm where you can send the instructions to the assets. The assets don't have to be wrapped and transferred, moving around to different chains, which allows us to create this global liquidity pool and global accessibility for your application. And so there's two typical design patterns that arise when we're thinking about sending the assets to the program versus program to the assets. So one is the home-based satellite, or it's almost, you can think of it as a client server. So we have a home chain where your master contract lives, and it acts sort of like a database, and then you have client contracts which are deployed onto all the other chains in our network, and they understand how to send and receive state to this home contract. And then we have sort of the peer-to-peer or flat model where all the contracts are basically symmetrical and they know how to send and receive messages. And rather than coordinating state, they're, I guess, coordinating more complex multi-transaction operations and just hiding that from the user. So yeah, examples of these different models on our network. So Prime Protocol, which is running our testnet at the moment, it's cross-chain lending. What it allows me to do is lock collateral on any chain on the Axelar network, and then have that create a portfolio which I can then borrow against, and I can draw down on that line of credit and get liquidity on any other chain. And so the way this is working is essentially the assets aren't moving between the chains. We're not having to create one central liquidity pool on the home contract, which is on Moonbeam. What's happening is we're just sending the instructions to the satellite contracts to lock the assets, and then we're doing bookkeeping on the home contract, which creates just one global portfolio, which I can then draw down on. So another example, this is more of the peer-to-peer model. We have Squid, so they're a liquidity routing protocol. What that means is basically you can do cross-chain swaps. Similar to the native USDC example, except instead of transferring USDC via USDC's bridge, you can use any of the assets on our network. So the way that the contracts actually work in this case is I'm going to send a request to the Squid contract on any chain. They're all exactly the same, and say I want to, for example, I've got ETH on the Ethereum chain, and I want AVAX on the Avalanche chain. It's going to execute a swap for me on Ethereum via Uniswap maybe. Then to get USDC, it's going to send USDC or any other transfer asset to Avalanche. Then the Squid contract on Avalanche is going to receive that message, and it will contain the instructions. Okay, I now want to swap this for Avalanche, and then it will do that swap and send to the user's destination address. So you've got this multi-stage transaction being hidden behind this contract, which is symmetrical across every chain. So yeah, typically in the past when we've been developing applications on-chain using Solidity, we're in a single-threaded environment essentially, whereas now we're going multi-chain. So we've got some of the same message communication patterns that we use in distributed systems start to pop up. So for example, we've got these two-way calls where I'm going to actually send a reply with my request. So for example, maybe I want to lock some liquidity on another chain and then get a response with how much I've got available, maybe in Prime. And then our infrastructure is actually going to automate all of that for you as well, so you don't actually have to build anything off-chain to support that. You just send the request to the contracts. And then we've also got this for-call feature. So what that provides you is essentially instant finality. So you make the request, and then some off-chain services are going to go and immediately deliver that request to the destination, and then it's going to get settled through the Axelar network, which is limited by the latency of the source and destination chains. So yeah, I'll run through the actual tooling that we provide. So the most important part of this is the contracts, which let you just tap into our services and create this seamless one-click experience. But then we've got the API and some other traceability and testing tools. Yeah, so the way the execution service works is all you have to do is pay gas in the same transaction as your request. Sorry. Yeah, so there's no need to build anything on top of Axelar to actually make sure your request is executed at the destination. You can use our service, but the benefit of that is it's completely composable and upgradable as well and permissionless, so you're not reliant on our services. You can build your own executors. You can, eventually we anticipate like a marketplace for different executors for different types of services. So you're not locked into just using the infrastructure we provide. Everything that sits on top of our network is completely permissionless. And we've got this really nice tool called Axelar Scan, which I'll try and open here. Is that showing? No. So what Axelar Scan gives you is complete end-to-end visibility over of any cross-chain requests. So we can see here we've got call contract, i.e. we're sending some instructions from Moonbeam to Polygon. And then if I go into that specific transaction, I can see links to the actual block explorers to see all the information for those transactions on their respective chains. But then we also have these status updates here, so we can see when the contract call was actually made to the gateway, and then we can confirm that gas was paid for it. And you can see down here, call approved means that it was transferred through the Axelar network, successfully authenticated on the destination chain. And then the final steps here are the executor services, which will come along and actually read those instructions, execute them, and then refund any gas that wasn't used, due to market fluctuations or what have you. Yeah, and then the SDK is where you access Axelar's state from your client front end. So you can query the state of any transactions, and you can actually subscribe to updates as well, so that your front end can be completely event-driven. You don't have to tap into all the different chains on our network individually. You just use one endpoint, and you can access everything. And then there's also utilities like being able to get fee estimates for how to interact with the gas contract. And this, essentially everything you have in Axelar Scan, you can access via this API. So if you're developing if you're doing development, then Axelar Scan is kind of your go-to endpoint for all the data that you need to be able to actually trace and debug and so on. So for actually building applications, we've got a full local development environment. So you can spin up an entire Axelar network on your machine, and that can be either with test chains using Ganache, or you can hook it up to live test nets. Obviously, the benefit of using Ganache is you can test things really, really quickly without having to wait for things to finalize. And we've got all the tooling you need to basically, you just write your contracts and you can deploy them straight into that network. You don't need to do any customization there. So the workflow is you basically just clone this local development environment, and then you can either clone our examples or you can start building your own contract code. So as far as actually writing the contracts, all you need to do to support general message passing is inherit a contract interface, and that will allow your contract to send and receive messages on Axelar. And then we've got various other utilities you can use. So there's constant address deployer. So one nice thing you can do is deploy your contracts across every chain with the same deterministic address, which means they can authenticate to each other. It makes communicating and trust really simple. And then there's upgradability and deployment, all the normal sort of stuff you'd need. So I already sort of talked about that. Yeah, so some of the important examples I would go and look at, particularly you've got cross-chain tokens, so you can plug this Axelar interface into your ERC20 and make it cross-chain native, so you don't need to make a separate call to our gateway to actually transfer the token. The method can be built into the token contract itself. Another really cool one is the NFT linker, so you can send any NFT cross-chain. You don't need to register on our network. It's completely application layer in the contract. I already talked about two-way calls, but there's also ordered execution, so essentially attaching a nonce to your requests to guarantee that they're ordered in the correct way on the destination. So yeah, let's go build. Check out our Discord. On our docs, we've got some really simple getting started 5-minute examples you can use, so I'd recommend go and check those out. And yeah, thanks everyone for coming and checking Axelar out. Yeah.